Hello everyone. In this video, we are going to construct a DFA which checks whether the given binary number is even. A binary number is made up of 0 and 1. So, sigma, our input alphabet is 0 and 1. And whenever a binary number ends with 0, it is always even number. And whenever a binary number ends with 1, it is an odd number. So, for example, 0, 1, 0, 0. The decimal equivalent for this binary number is 4. And it is an even number. And 0, 1, 0, 1. The decimal number is 5. 5 is an odd number. So whenever a number, binary string ends with 0, it is an even number. If it ends with 1, it's an odd number. Another example is 1010. The decimal equivalent for this binary string is 10. 10 is an even number. And 1011 decimal equivalent is 11, and it is an odd number. So whenever the binary strings end with 0 means even number, ends with 1 means odd number. So to construct a DFA, we need two states here. So we are going to consider Q naught for all the binary strings ending with 0. And consider Q1 for strings ending with 1. So, Q naught is also the start state as well as final state, because we are going to check the binary number is even, whether the binary number is even. So, the string ending with 0 is a final state. So, Q naught is both the start state as well as final state. So, now we will construct a DFA diagram, transition diagram. So Q naught is start state as well as final state. So in Q naught, if 0 is the next input, then it should remain in the same state, right? Because the string ends with 0. So it should go to, if a string is 0, it should go to Q naught. Then from Q naught, 1 goes to Q1 because the string ends with 1. In Q naught, if 0 is the input, 0 is an even number, right? So it should go to the final state Q naught, and from Q naught, if the next input is 1, 1 means the decimal equivalent is also 1. It is an odd number. So it should go to Q1. Similarly, from Q1, if the next input is 0, we have already recognized 1. We are in state Q1 after reading 1 only. So after reading 1, the next input is 0. Means then the decimal equivalent for this number is 2. 2 is an even number. That is, the string, binary string ends with 0. So in Q naught, if 0 is the next input symbol, then it should go to Q naught. So from Q1 to Q naught, draw an arc, and that arc should be labeled by 0. Then 1. We have already recognized 1. Then from Q1, if the next input is also 1, means it ends with 1, right? The decimal equivalent is 3 and it is an odd number. So it should remain in the same state. So this is a DFA diagram for checking whether the binary number is even. So consider this 1010. This is an even number. So this string must be accepted by our DFA. So 1010 means 1010. So we are reaching the final state. We are in final state after reading all the symbols of the string. So we can say that this string is accepted by our DFA, and this odd number should be rejected. So 1011, 1011. We are in non-final state, so that it is rejected by our DFA. Similarly, if we want to check whether the binary number is odd, means instead of making Q naught as a final state, we have to make Q1 as a final state. Then now we can construct a 5-tuple notation for this. So DFA, D or A, any name can be given. Now we have to write the set of states. Set of states are Q naught and Q1. Then input symbols 0 and 1. Delta is a transition function that is represented as a diagram here. We can also write as a transition function representation. So delta, then start state is Q naught, final state is also Q naught. We can also represent it as a table. So table means all the rows corresponding to the states. So here there are two states, Q0 and Q1. Q0 is a start state as well as final state. Start state is represented by an arrow and final state is represented by star. So both are pointing to Q0. Q0 is a start state as well as final state. Then the columns are the input symbols 0 and 1. So now we can fill the table. So Q0 0. From Q0 0 goes to Q0. From Q0 1 goes to Q1. Then from Q1 0 goes to Q0 and from Q1 1 goes to Q1. So this is the DFA for checking the binary number is even. Thank you.